In this question, we are asked to show the number of ways to select a delegation in which neither of the twins is selected is k times of n minus 2n plus 6. So to start off this question, let us just tabulate the number of badminton, floorball and swimmer players we have. Right? So for badminton, we have 5. For floorball, since we are not going to include the two twins, the number of players will be n minus 2 to choose from. Swimmers, 6 players. So let's break down this question into 3 cases. So for case 1, the number of possible combinations will be 1 badminton player, 1 floorball player, and 2 swimmers. So likewise for case 2, I can have a combination of 1, 2, 1. And the last case, I can have 2, 1, and 1. Okay. So now let's write out the number of ways to select the players in each case. For case 1, since we are selecting 1 out of 5 badminton players, so number of ways will be 5 choose 1. We are selecting 1 out of n minus 2 floorball players, so number of ways will be n minus 2 choose 1. And swimmers, we are selecting 2 out of 6, so will be 6 choose 2 ways. Right? So similarly for case 2, I will have 5 choose 1 ways to choose the badminton players, then n minus 2 choose 2. And for the swimmers, I will have 6 choose 1 ways. Okay, and for the third case, I will have 5 choose 2 ways to select the badminton players, n minus 2 choose 1, and 6 choose 1. Okay, for the first case, let us try to simplify the expression. So 5 choose 1 basically is 5. n minus 2 choose 1 is n minus 2. And 6 choose 2 is actually 15. So this works out to be 75 times of n minus 2. Okay, for the third case, 5 choose 2 is actually 10. n minus 2 choose 1 is n minus 2. And 6 choose 1 is 6. So this is 60 times of n minus 2. Okay, for the second case, it needs a bit more working because we are dealing with n minus 2 choose 2. So changing this to the expression that involves a factorial, note that n choose r is basically the same as n factorial over r factorial multiplied to n minus r factorial. Okay, and this is actually given in the MF 26 under the binomial expansion. Alright, so n minus 2 choose 2, we will have n minus 2 factorial over 2 factorial and n minus 2 minus 2, which is n minus 4 factorial. Okay, which can be further simplified to n minus 2 times n minus 3 times n minus 4 factorial divided by 2 times of n minus 4 factorial, and of course we can cancel the n minus 4 factorial, hence leaving us with half of n minus 2 n minus 3. Okay, and we can put this expression back into what we have in case 2 for n minus 2 choose 2. Okay, and then multiply with 5 and 6. This will actually give me 15 times of n minus 2 n minus 3. Okay, now let's add up the total number of selections. So in this case, the total number of selections is given by 75 times of n minus 2 plus 15 times of n minus 2 n minus 3, and the last case is 16 times of n minus 2. Alright, okay, I'll leave it to you to actually further simplify this expression, and we actually can leave it in a very neat factorized form, which is 15 times of n minus 2 n plus 6, and hence the value of k is 15. Okay, now in part 2, we are given that the number of ways to select a delegation in which neither of the twins is selected which is basically the answer from part 1, okay, is more than twice the number of ways to select a delegation, which includes exactly one of the twins, and we are asked to find the value of m. Okay, now what we need to do is to actually work out the number of ways to select a delegation which includes exactly one of the twins. So recall just now what we did was we tried to tabulate the number of players in each sport. So for badminton, floorball and swimmers, we actually have 5 players in badminton, m players in floorball including the 2 twins, and 6 swimmers. Alright, so what we can do now is, again, we break them down into cases. So we have case 1. Okay, we will have one of the twins selected from the floorball players. So the number of ways will be 2 twins, selecting 1, so 2 choose 1. Then we choose 1 player from the badminton players, which is 5 choose 1. And then we will have 2 swimmers, alright, selected, so we have 6 choose 2. Okay, then for case 2, alright, same thing, I'm going to select 1 out of the 2 twins, so 2 choose 1. But now I'm going to select 2 badminton players, so that will be 5 choose 2, and 1 swimmer, 6 choose 1. Okay, what about case 3? So in this case, same thing, 1 out of the 2 twins selected, but now the thing is I'm going to select another floorball player, which is not the other twin. So the number of players I can choose from will be m-2 floorball players. The remaining m-2 floorball players, choose 1. Right, so now I'm choosing 2 floorball players. One of them is actually the twins. Right? Then I will have 1 badminton player and 1 swimmer. Adding up the 3 cases, you will get a value of 60m plus 150. Okay, now we can link this back to the question, okay, and try to relate to the answer that we have in part 1. Right? So the question says that the answer in part 1, where neither of the twins is selected for the delegation, is more than twice the number of ways to select that includes exactly one of the twins. So the answer in part 1 that we have is actually 15 times of m-2m plus 6, and this is actually greater than 2 times of this value that we have, which is 60m plus 150. So what we've seen here is we have set up an inequality, and how do we actually solve this inequality to find the least value of m? Now what most of the students did was they tried to actually solve this inequality algebraically for m, but in this case we are not restricted for the use of GC, so we actually can use the GC to help us get the value of m more quickly, and this is what we can do. Okay, you can enter the 2 expressions into your GC y equation, right? So we set up the 2 expressions here, y1 and y2, right? So this is basically what you have from part 1, and this is what we have calculated in part 2. So remember that what we are looking for is we want to find the value of m, which in this case is represented by x, right, such that part 1 is actually greater than part 2. So after we've input the 2 expressions into y1 and y2, to get the values, okay, of these 2 expressions, we can then go to the table columns. So this is what we have from the table. So remember that what we are looking out for is for y1 to be greater than y2. So if you look at the 2 columns represented by y1 and y2, we will see that when x equals 9, which is at this point here, your y1 value is actually greater than y2. Okay, and the question is asking for the least value of m. So the least value of m for this case is actually 9, and that is the answer for this. For the last part of the question, we are actually arranging the group around a table, very importantly, with distinguishable seats, meaning that the seats are all different. Alright, and then the certain conditions imposed. It says that the pair of twins is to be seated together, and then the teachers are to be separated. So let us draw a diagram to illustrate this problem. So basically we have the pair of twins, so let me call it W1 and W2, which has to be seated together. Then we have the teachers, let's call them teacher 1, teacher 2, then these two have to be separated. At the same time, we have one badminton player chosen and one swimmer chosen. So remember, recall this type of questions which involve separation, which will involve the slot-in method. So first, let us just ignore the teachers from the arrangement. So by looking at the pair of twins seated together, the swimmer and the badminton player, so to sit around a circle with seats that are actually identical, let us consider the distinguishable part at the later part of the solution. Okay, let's first consider the 3 blocks, right, seated around a table without distinguishable seats. And the number of ways to do that would be 3 factorial divided by 3. So remember, you have to divide by 3 because we are talking about circular permutation. Okay, then after which, what I can do is the block of twins, they can swap position, so that would be multiplied by 2 factorial, or just simply 2. Okay, now coming back to the 2 teachers, they have to be separated. So as I mentioned, if the objects involve separation, think of the slot-in method. Okay, so how many slots have I created? 3 slots. So 3 slots, choose 2 to put in the 2 teachers. So let's say I've selected the slot T1, T2 for the 2 teachers, and these 2 teachers, they can actually swap the position. So I can have T2 here and T1 in this slot. So what I need to do is I need to multiply by another 2. Right, so this is the total possible number of arrangements if the seats are identical. Right, but now the thing is, we are looking at seats that are distinguishable. That means all the seats are all different. So what I need to do now is I just need to take this arrangement, multiply by 6, which will give us a value of 144. Right?